Hi, my name is Fox. Welcome to Automation Workshop. On this video, I'm gonna take you through the things we're gonna do in the workshop. But before we can go into what we're gonna be doing in Automation Workshop, uh, surely you've heard a lot about 4IR or Fourth Industrial Revolution, and sometimes you wonder what is Fourth Industrial Revolution. Well, fourth industrial revolution is the development of technology. It started back then in 70s, around 1765, where we were introduced into first industrial revolution, where we speak of the steam engine. Then we moved into the technology grew, and we developed into second industrial revolution. We're now we're introduced into electricity, which promoted mass production, where factories were able to produce a lot of things in a given time. Then time went by. That industrial revolution, it was the introduction of electronics, robotics. When you go to BMW manufacturing plant, you'll see that most of labor is done by robots. It's robots which do the welding and all those things. Um, and now you hear about the fourth industrial revolution. Fourth industrial revolution speak of the Internet of Things. It speaks of big data. Speaks of artificial intelligence. It speaks of the cloud. It speaks of things like IoT. IoT, it's industrial Internet of Things. It speaks of cyber physical systems. Like for instance, Internet of Things. Internet of Things speaks of everything will be connected to the internet. That you'll be able to communicate with your smart house using your smart device. Like you'll say, for instance, we have like Alexa from Amazon. We also have this AI by Google. So you can command Alexa to say, Alexa, please switch on the air conditioner and make my room to be 25 degrees Celsius, so that by the time you are you reach your house, your room is already at that particular temperature. Most of the things now are migrating into being digitalized. We are in a digital era. Most of the things um, are digitally. We do things digitally. So the picture that you see there, it was during the second industrial revolution. They were producing a product. But if you can look in that manufacturing factory, how many people are there? You had a huge number of people. One section doing this, another section doing this, another section doing this. Then we have a final product. And it used to consume, um, it used to demand too much labor, and it used to take time. Well, I'm gonna take you through automation, what we're gonna do in the workshop, and what's the link between the fourth industrial revolution and automation. Once more, welcome to automation workshop. These are the things that you're gonna do, or we're gonna do. Right now in this video, I'm gonna cover the introduction of automation, the benefits, and the basic element of automation. We're gonna do instrumentation, we're gonna do relay logic, we're gonna do PLC, we're gonna do pneumatics. We're gonna go in depth as we proceed. One may ask, what is automation? Automation is any system or anything that works with a minimal or without a human assistant. So if you go to the workshop, let's say for instance after lunch or in the morning, you'll find the workshop dark. The moment you step in, then the light turns on. No one is switching on the lights. They switch on automatically because of a PIR sensor. The motion detector detects your motion, then switch on the light. As you leave the workshop, the motion detector detects that there is no one in the workshop. Then it will then turn off the light. The manual way of doing it is the way we do it at home. Like we have a switch on the wall. When you wanna switch on the light, you press the switch, the light comes on. You press the switch again, the light comes off. That is the manual way of doing it. To automate it, you just put a sensor that will detect if there is someone in the room, then the light will be on. If there is no one, the light will switch off. Another example will be we've heard of automatic cars. So what happened on the automatic cars, instead of you changing the gears, the car changes the gears by itself. As you accelerate, it will change to gear 2 to gear 3 as you accelerate. The only thing you have to do is to accelerate or brake. Okay. So during the first industrial revolution, as I've mentioned, that it was when we were introduced into steam plant or steam engine. Then second industrial revolution, it was mass production. So during mass production, we had people who were doing work manually. Everything was done manually. As you can see on my phase one, this is how we used to, or they used to manufacture or produce something. We will have an input of which will be your raw material. Then we must have something like a process which will process then that raw material. Then we'll have something, a final product, of which will be your output. So here it's when everything was starting. Then we manually do the work, or manually, let's say we're producing a pen. Everything was done manually. The tube, the ink, and everything. This person will deal with the tube. This one will deal with the ink. This person will deal with the cover. This one will deal with the tag. If it's a red pen or a yellow pen, then you get a complete product. As the technology migrated, then we were introduced into automation. Then it was an automated system. Then someone will do things like sorting or handling, then to another automated section, then another person, automation, then we have a final product. But as time progresses and as the demand of the product increase, automation or automated systems are highly recommended because of the amount of product that an automated system can produce. As you can see in this phase, this is the phase we're gonna be migrating to as we are being introduced into the fourth industrial revolution, where we are introduced into robotics. Robotics in the fourth industrial revolution through Internet of Things and SCADA. What is SCADA? SCADA is supervisory control and data acquisition. Like robots will be able to communicate with one another to say, okay, I'm done now inserting ink on this tube. Get ready to put a tag. Then it will transfer that particular product into another station, so on, so on, so on, so on. So as the demand or the productivity increase, it is highly recommended that we use an automated system, because with manual takes time. Takes time, guys. Takes time. So, let me clear the screen. So what I was explaining basically is what you see on the screen. So our product used to start here, then with manually work or with your hand tools, you will do the job, of which will be the process. Then we'll have a complete product. Then we migrated into a second or third industrial revolution. Now it's both human and a machine that do the work. It's a human and a machine. If you go to most of manufacturing plants today, you'll see there is a section where there is a robot that does the work. When the robot is done, a human being will take that to another station. But as we move into the fourth, or as the technology progress, it will be machines that will do the work, because they will be automated. Everything will be done automatically. So we have three types of automation. We have programmable automation, we have flexible automation, we have fixed automation. Programmable automation, are those automation where you can manipulate or you can change the algorithm. You can say, today we are manufacturing a 2 series. Just like on this picture, these robots, you can change the robot to say, today please produce a 2 series. Tomorrow the robot will produce a sedan, or will produce you can change. You can have a variety of products that is produced by this robot. Like today, this robot, you can teach it to produce this kind of a product. Tomorrow you teach it, produce this kind of a robot, produce this kind of a robot. So because of its flexibility in producing different types of product, the quantity of production, it is less, because it is diversified. You can teach it to do this. Tomorrow you tell it to do this. As you can see, it is not able to produce a huge number of products, unlike a fixed automation. Fixed automation is that particular machine or a system that was just made to produce that one product or to do that one job. For instance, a conveyor belt. Conveyor belt was just made to transfer goods from point A to point B. Hence, a conveyor belt can transfer thousands of products, because the only function or the only thing that a conveyor belt can do is to produce that one product. Then we have flexible. Flexible, they fall in between. Like they can You can change it today. You see on my picture here, my yellow robotic armor. Today you can teach it, okay, produce this, uh, but not at a larger scale. Produce this like this. Like, it is flexible, but not like a programmable. A programmable is extremely flexible. It can do almost everything. You can program it today to do 1, 2, 3, tomorrow 7, 5, 9. But with a flexible can falls in between a fixed and a programmable. So, what are benefits of an automated system or automation? Or why do we have industrial automation? Automation uh, reduces labor cost. Remember the picture I showed you earlier on with a manufacturing fetch with a huge number of people. Those people can be replaced by few robots that can do the things that they were doing at a high rate. It reduced the operation time and work handling time, because robots, they are just robots. You can program it to produce these products much faster than us, because us as human beings, we have a lot of interference and we have a lot of mistakes, and those mistakes sometimes they reduce the quality of the product, of which the automated system improves the quality of the product, because it is precise and it is accurate. Like, if you say cut 5 millimeter, it will cut 5 millimeter, it won't cut 4,9. But with us, sometimes we can cut 4,9, you see, and that might affect the quality of the product. And it automated system can achieve what we cannot achieve as human beings. Okay. We have building blocks when we are building an automated system, or when we are automating something, changing something from manual to be automatic. We have I only listed these are basic elements: control systems, sensors and actuators, and logic controller. So, control system, it's when now you'll have to choose, or it's in your development phase, where you plan your system to say it is going to be an open loop system or a closed loop system. How is this going to happen? If 1, 2, and 3 happens, what must happen after this? You see, when you are building your logic. Then we have sensors and actuators. Sensors and actuators are actually the one that does the physical job. Sensors, they bring information or the state of your process to your logic, to say, okay, and now this is what is happening. Then the logic controller must execute a decision. When the decision is executed based on the algorithm that you write, or based on the logic that you are building for your system, then the actuator will do the physical job. So actuators, they receive commands from a logic controller, and they execute a physical work. Things like motors, things like if you are working with pneumatics, like things like cylinders, pneumatic cylinders. So anything that does the physical work, or converts the signal or the command into physical action, it is an actuator. Actuator is the one that will do the job. Then a logic controller is where now you will build a logic to say, after 1, 2, and 3 happens, this must happen. If this happens, this happens. For an example, right now, if you go to most of the garage, they have automated doors. As you approach, the door will open automatically. without any person opening the door. So the decision is made on the controller of that particular system to say, whenever a sensor detects if detects that there is someone approaching the door, the the door must open. As when someone approaches, the sensor will inform the logic controller. The logic controller will say, okay, actuator, open the door. Then the motors will rotate, then the door will open. Okay, so I have some few videos I want to show you of automated plants. Remember, I said automation increase the increase the production and reduce labor cost, reduce working time. So here I have the factory. Uh, Coca-Cola factory, 25,200 bottles per hour. As you can see in the factory, it is empty. We only have this Madala working in the factory because most of the things are automated. Here we have okay, I don't know what is happening with my video. My computer, it's doing things. Uh, and now the bottles are being washed. It's rinsing, it's filling. Pneumatic system. When we come to pneumatics, I'm gonna explain some cylinders and some pneumatic systems. We have an actuator here. We have a motor. Just look at how many bottles or how many Coca-Cola this factory produce. Uh, with humans doing this, was Coca-Cola gonna be able to produce this number of Coca-Cola in a short period of time? So technology really helps us to buy time. it reduces working time, and it it brought these things to say things that we're not able to do. You see, this is a sensor. Uh, Technology can achieve those things. Remember the phases that I showed: phase one, phase two, phase three. So what is happening in this factory is actually uh, phase four, phase three, where it's monitoring or checking how the system is. Automation comes to take people's job. Well, it's both true and false. Well, in each and everything, we have a good and bad side of it. Technology have come to make life easy, and the bad side of it is that most of hard labor job are being replaced by the robots. But now, who's gonna do maintenance on these robots? Who's gonna program this robot? Who's gonna build these systems? So, what is happening? There is a shift in the job market. You see, these sensors they count how many packs have passed. Now here they're gonna be stacked. So fourth industrial revolution is not only gonna affect the engineering job market, but it is gonna affect a lot of job. There is a shift in the world of working. There is now a new, better way of doing things. As you can see, the robot can stack that nicely and accurately without any human error. And as automation comes, it makes the working environment much safer than it is when it is human beings who do most of the labor. So remember the three basic elements I spoke of which is control systems, sensors and actuators, and logic controller. So most of the factories, or most of in the industry, you'll have different uh, types of controllers. We're gonna be doing PLC, but I'm gonna expand as we get into that section of PLC. Then it's done. The product is ready for market. Instrumentation is defined as the art and science of measurement and control of the process variables within.
Modern food and beverage manufacturers have some complex recipes to follow. Along with flour, cocoa, and sugar, manufacturers also need to mix in key ingredients like traceability, quality control, productivity.
My computer is messing with me. Okay, so I was saying instrumentation is defined as the art and the science of measurement and control of process variable within a production or manufacturing area. Uh, what do I mean about process variables? We have 4 process variables that we're going to be controlling, of which is pressure, temperature, flow, and level. Although we have other process variables, but the main focus will be on those 4. The other process variables might be um, uh, conductivity or pH, which check if the how check the acidity of a substance, if it's acid or a base. So let's move to control systems. We have 2 types of control loops. We have an open loop control and we have a closed loop control. With an open loop, there is no feedback to your controller to inform it about the state of your output. If what you set on your input to say, I want this kind of a product at this value or ratio. With an open loop, there is no link. For instance, a good example of an open loop system is of a washing machine. There is nothing that tells the washing machine whether your clothes are fully washed or they are not washed. It only depends on the timer. Most of the open loop systems, they are time-based program. There is no link between an output and the controller. For instance, a microwave. When you warm food on your microwave, you set the timer to say 2 minutes. Whether your food is warm or your food is not warm, or your food is half cooked or your food is fully cooked, the microwave will say, I'm done. Come and take your product. That's an open loop. But with a closed loop system, there is a feedback mechanism. There is a feedback signal to your control to say, the product or the set point that you said you want and what I have on the output is this. Then the controller will make a decision to say, okay, you output, you have deviated from what I have on the set point. For instance, as you see on my picture, I have a guy who is having a valve. So here on top on this controller, it's where I will put my set point to say I want a level of 50 in this tank, and I have a sensor of which is a radar. If it will check the level in this tank, then it will inform the controller to say, okay, in this tank I have about 49.8 level of water. Then the controller will execute a decision to inform the input or the actuator to say, oh, open at this angle, open this much, because now I have about 49.8, so open slightly so that I can just reach my set point. For instance, a good example of a closed loop system will be your air conditioner. You set your air conditioner into, let's say you set it into 15 degrees Celsius. Uh, when it's hot outside, you just want your room to be cool and cold. So whenever there is a disturbance in the temperature of your room, of which will be your process, let's say someone comes and open the doors and the heat comes in, the temperature starts to rise. As the temperature rise, the sensor will sense that, oh, the temperature has rose. Then it will inform the controller. The controller, like, okay, if the temperature goes this direction, I must increase the coldness so that I will reach my set point, of which will be 15 degrees Celsius. So we'll talk about things like PID controller, of which is proportional, integral, and derivative. We're gonna deal with it when we come into uh, instrumentation section. So this is the panel that you're gonna be working on in the instrumentation. We have different types of instruments. We have a pump, we have a gauge, we have the instrument that you saw, this one and this one. These are transmitters. We have a transducer. The transducer, it converts one form of energy to another. It will, for this one, it converts electrical signal into pneumatic signal, because this actuator or this control valve only understand a pneumatic signal. So uh, on your controller, you'll inform your actuators to say open uh, 50 degrees, 50%. That signal is gonna be transferred through electrically. It's gonna be, if you are using a PLC, it might be 4 to 20 milliamp signal. Then it will come to this transducer. Then the transducer will convert it into a pressure. Then this will open according to the pressure applied. Okay, we have here a sensor, as I've explained earlier on. That sensors, they inform the control uh, inform the logic controller uh, about the state of your process, or of your system. Things like push buttons, or here I have a capacitive proximity sensor. It only detects it detects anything. If you bring anything close to it, it will detect, then it will send a signal. So we have two types of signals. We have a digital signal, we have analog signal. That capacitive proxy sensor only produce a digital signal. It's either you get one or you get a zero, you get a low or you get a high. If you are working with 24 volts, most of the things in automation will be, most of our controller understand the 24 volts. It will be either 0 volts or 24 volts. That's a digital signal. It varies between those two states. With analog it's continuous. It changes. Like for instance, 0 to 10, 4 to 20 milliamps, 0 to 20 milliamps. These are the things we're gonna cover. I've explained of a pneumatic signal. When we come to instrumentation section, okay, we're gonna have relay logic, where you're gonna build logic using relays. A relay is an electromagnetic switch which have contacts and has a coil. As you energize the coil by applying the voltage to it, or it will change the state of your contacts. So, for instance, in this system, for you to fill up this tank of water, and when it's full, the pump will stop feeding the tank. You'll build a system. You'll connect your relay circuit. You'll build the logic to say whenever a low level switch is triggered, start filling water. Whenever a high level switch is triggered, stop filling water. This is an example of an on and off system, of which we'll expand more when we get to instrumentation section. Then we have we have PLC. It's a section where we're gonna build systems using a programmable logic controller. A PLC is a specialized computing used in process automation with it has a programming memory for an internal storage of your instructions or of your logic, and it has input module and output module, where in input module you'll connect all your sensors, and on your output modules you're going to connect all your actuators. We have different brands we're going to be doing training on. The first one will be Siemens logo. The second one will be Allen Bradley Micro 820. We also have Siemens S7. We have Schneider. We have Schneider. We have Unitronics. Unitronics. Oh, it is a wonderful PLC. But I'm gonna show you the project from Unitronics. So the architecture of a PLC. A PLC is made up of input module. Then it has a CPU inside, user memory, data memory, then serial port. Serial port is where you're gonna have your communication between your programming device, of which will be your computer, and the PLC. Then it has an output module. We're gonna expand more when we get into workshop. This is a basic PLC program. Here we are using a ladder. You're gonna learn other languages like function blocks and structural tags. So this is a project of a Unitronics PLC. Unitronics PLC, what's nice about it is that it consists of a PLC and an HMI. What is an HMI? HMI is a human machine interface. HMI gives you access to interfere with the process, to see what is happening in the process. Most of them, they are a screen where you can set parameters to say, I need this amount of water, I need this amount of sugar, I need this amount of heat, and this must rotate for this long. Then I must get my output. On your HMI, you can then go press start, press stop, check the trends, check everything that you want to check. Here on this project, we're designing a robot, a traffic light, of which you're gonna program when you get to the workshop. In this one PLC, we're able to build two systems, one system for a traffic light and one system for a motor for reverse forward. Right now we are changing into the motor section. Now it's running on reverse. After seconds, it run to forward in one PLC. But you're gonna see these beautiful things when you get to the workshop. Automation, it is the workshop of innovators. You're gonna innovate. You're gonna build systems. Then you're gonna go to pneumatic section. What is pneumatics? Pneumatic is the use of pressurized air to control mechanical workpieces. So we use compressed air to do the work. It is so wonderful. This is one of the best section. Surely you're gonna enjoy to say this air that you breathe can actually do work. You can actually use it to automate some of the things. It is beautiful. It is beautiful. Uh, the application of pneumatics is clamping, shifting, positioning, orientating, picking and places and place. Why pneumatic mostly used for this type of application? Pneumatic is cheap to install and to maintain. It is clean and it is safe. It is easy to use than the other systems. So these are the pneumatic components. You see them. We're gonna go into details in other videos. I'm gonna put the links below, links for all the section for PLC, link for pneumatics and for instrumentation. So these are the control valves for the pneumatic systems. And we have a two by two way. The first two represent the number of ports and the other two represent the number of positions. But don't worry, when we get into pneumatic section, we will go into depth. You'll get understand what we mean by 2 by 2. This is how we build the pneumatic circuits. This is a single. This is the a single acting cylinder. It has a spring inside. As you apply pressure, it will advance. As you cut pressure, it will then retract automatically because of a spring. I have another video of a Festo station that we have on the P2 section of automation. Let's take a look.
Increased productivity and greater quality. Successful manufacturing companies achieve these aims with innovative automation technology. Experience the fascinating processes of automation. Discover a world in which state-of-the-art technology controls material flow, handling systems, and robots. For operating personnel, maintenance and troubleshooting are of key importance in ensuring that the systems don't go down. There's great demand for specialist knowledge and system expertise. Festo Didactic has developed an industry-focused learning system to provide the FMS50 network system and stations and modules right down to the individual component. FMS50 can be used to clearly illustrate automation in all its complexity. Innovative software and a broad range of media convey knowledge about specific topics and technologies. These include learning and simulation programs on pneumatics, hydraulics, PLC technology, and robotics. Mechatronics Assistant gives you both modern documentation on CD-ROM and training material in one. Accompany a workpiece on its journey through the FMS 50 system. The distributing station separates the blank from a magazine. A changer moves it to the next station, which checks it.
How beautiful automation it is.
Material recognition, material transport, height measurement. The blank is checked and then passes via an air slide to the production process. Apropos transport, in the FMS 50 system, many different pneumatic drives join to ensure optimum material flow. Standard cylinder, swivel cylinder, linear drive, short stroke cylinder, rodless cylinders or flat cylinder. Each drive type has its own special advantages. But let's get back to the assembly process. The pallet transport system brings the blank to the next work cell, where the blank is transformed into a cylinder body. Grip workpiece, transport, set down. The rotary indexing table positions the blank for drill hole checking. Machining and collection. A handling device with a pneumatic gripper transports the finished cylinder body back to the pallet. A suitable gripper is required for each handling task. For example, a parallel gripper with different kinds of gripper fingers, or a suction gripper, or a robot gripper. The next work cell tests whether the cylinder body can be assembled, and it does this right on the transport pallet. The highly flexible camera system detects errors immediately. Are all 3 tabs present? Are the dimensions correct? This helps to ensure the quality of the assembly process. The cylinder body reaches the assembly station. Grip and move. This is an easy task for an industrial robot if it's correctly programmed. Position control. Here a reflex sensor with optical fiber helps out. The reflex sensor is just one of many sensors in the FMS 50 system. There are roller lever actuators and micro switches. Fiber optic sensors. Inductive, capacitive and optical sensors, all delivering the right signals for the controller. They are the senses of an automated system. Back to the cylinder assembly. Fetch the cylinder piston from the magazine. Insert it. Remove a spring from the gravity feed magazine. Install it. Pick up a cylinder cap. Orient it. And screw it onto the cylinder body. The interaction of software, electronics and mechanical elements is particularly impressive in this robot assembly station. The cylinder is now assembled. It's placed in storage via the pallet transport system. A multi-axis handling system with parallel gripper picks up the cylinder and places it in a free storage location. DC servo motors drive the axes of the handling system, which can move to 20 different storage locations. And by the way, there are many electrical drives in the FMS 50 system. AC motors with frequency converters, for example. DC geared motors with helical gear unit. DC geared motors with worm gear unit, such as for driving the rotary indexing table. or the drilling spindle drive with planetary gear unit. If an order has been received, the transport system takes the cylinder to the outgoing goods area. This is Pick Alpha, a handling device with pneumatic drives from Festo. It picks up the cylinder and places it on the sorting conveyor. Sensors detect the color and material of the cylinder. They initiate appropriate sorting. The assembly process is now complete and the cylinder is ready for collection. A few more words about control. Distributed control is responsible for smooth operation of the system. Each station has its own controller. This results in small, simply structured units. The AS interface field bus distributes signals throughout the system and organizes optimum exchange of signals between the transport system and the station. System interfaces are clearly defined and identified. I/O terminals consolidate the signals and show the current status. The control panels of the individual stations are sturdy and clearly structured. The bottom line, the FMS 50 system from Festo Didactic is the ideal training environment for nearly all aspects of automation. The system offers cost-effective entry into the world of flexible manufacturing and integrated systems. Modular, expandable, and based on MPS stations.
So one may ask, where exactly can we use such application or a system in real? The company, they produce sensors. Here the company is producing cakes or biscuits, if you may put it. So the camera detects if all biscuits are perfect, they're in good shape, there is no defect. If there is a defect, it rejects it. So there is no need for a person to keep on checking if all the biscuits are rightfully cooked or rightfully arranged. These smart cams can detect, as you can see there, then surely that pack is going to be rejected. Look how many cakes are being produced same time. Automation is beautiful, eh? And this one detects, check everything. Then those which are approved are then packed, scanned, then the sorting will happen. Those that must be rejected will be rejected. Those that must be taken to the storeroom will be taken. So okay. I have another video that I have. Okay, basically on this video, what I wanted to show you is it's mapping. It's mapping how um, forklift, instead of having the forklift that too much space, you can have a pre-programmed forklift. There is a good factory that does this very nice, like Amazon factory and Alibaba's factory. I think I do have a video from Alibaba. That I'm gonna you should check so this is the final video that I want to show you how automation has really helped even during this it helped during this coronavirus crisis in China. That
机器人会根据这个空间的大小，自动的计算出我需要的照度指令，然后机器人还会通过各种各样的传感器检测这个环境中是不是有人。如果有人，它需要把对人有害的消灭方式能够关掉，并且语音提醒它离开。
我是防护公安巡逻机器人，警方提示，请大家戴好口罩，注意个人卫生，不要前往人流密集场所。身体若有不适，请及时就医。
两位大妈，请戴上你们的口罩，赶紧回家，赶紧回家！别看了，大妈，说的就是你，把口罩戴上，赶紧回家，赶紧回家！
有了这个体温检测系统以后，我们不用对旅客进行。
So that brings us to the conclusion of our introduction or welcoming into automation. I have my favorite quotes that I want to read for you. The first one by Tom. He said, "You are either the one that creates the automation or you are getting automated." Then Bill Gates said, "Automation applied in an efficient operation will magnify the inefficiency." Benjamin said, "Change is the only constant in life. One's ability to adapt to those changes will determine your success in life." As we are migrating into a digital era, as we are moving into the fourth industrial revolution, adaptation is very crucial to say what is it that is relevant for the time that we are in. So that brings us to the end of our lesson. Be safe. If you have any question, we're gonna discuss them on WhatsApp. Thank you for your time. See you in the workshop.